We've talked parameters and adjusting the minimum query coverage, identity, blast values. We selected our folder. We selected our output, the reference genomes, which we talked about choosing one genome, a FASTA file, or a feature group. Now we're going to talk about the comparison genomes. In the very introductory video for the proteome comparison, we talked about this being a bidirectional blast tool that's established with the reference. It's only going to show you the bidirectional blast hits of genes that are contained in the reference. If the comparison genes have something unique, you aren't going to see it, and you'll need to submit those as a reference genome if you wanted to see that later on. But let's look at how we can choose different comparison genomes. We can select a genome, we can select a protein FASTA file, we can select a feature group, or we can select a genome group, or any combination of the above. So we're going to select all of them. So let's say I want to select a particular genome. Right, the example we've been using is Brucella melitensis 16M, and we are going to look at comparisons across those genes. Maybe I want to look at a different Brucella melitensis genome, but I know that there's a vaccine strain called Rev1. So, and this is a high quality genome. Brucella have two complete chromosomes. One is a large circular chromosome, and then it's got a small circular chromosome. And this particular genome is a complete genome, meaning that it's got the two chromosomes, the contigs equal the chromosomes, and all the ends have been resolved. So let's click on that. And there it is, but to be included, it has to be added to this box. And Patrick has this handy dandy little plus sign here that shows you how to do that. Now let's add a protein FASTA file. You know we've uploaded one recently. You could either go into your workspace and find it, or you could click on this down arrow, which will show me the things I have added for FASTA files, the most recent. And here's this guy that I created. And these are the lipopolysaccharide genes from the 16M genome. If I use this particular genome as my reference, the blast hits should be pretty good. So we have to get it into this box. Let's click Add. All right, so you can see we've got this Rev1 genome here, and we've got the 16S here. If I want to get rid of anything, I can do it at this point. This is so much fun. Let's add a feature group here. We can dig down into the workspace, or once again, I can click here because I created a feature group pretty recently, which is right here. The 16M LPS genes that I added very recently. I click on that, and I don't mean to be redundant, but I am redundant, so I have to add that here. Now, this is the sequence of these particular genes, so it should look, this will be a great test to make sure the tool is working properly. We should be able to see that in the final diagram that's generated by this tool. These should look very, very similar. And if we use the 16M genome as the reference, there should be very strong homology. And now let's look at a genome group. I've created tons of genome groups in Patrick. It's a really useful way to narrow in on data that you're interested in. And I click down here to see ones I created recently. Hold on, let's show you how to do it here. And we go to, I'm just gonna click on created here. My genome groups, I click on that. And I need to see one I created recently. So I click on that, and you see I've got this group called test group proteome comparison, it's got 3 genomes. Now what's important about that is that this tool only allows you to compare 9 reference genome or 9 comparison genomes to a reference genome. So I've got to be under that magic number. But I click on that and I click OK, and it says here I found it, and I add it here. So I know that this has 3. This counts as 1, 4, 5, 6. So now we're set. All we have to do is assign our reference genome. And what I'm going to show you in the next video is the way I game this so I can submit multiple jobs at once. And hopefully you too, after you watch that, will become a whiz at proteome comparison. Thanks.